approximately 1,350 light-years away, D203-506 neighbours a hot, young, massive star that flood the region with strong ultraviolet light. But because UV radiation normally destroys complex organic molecules such as CH3+, discovering emission from the compound seemed curious. The team hypothesizes that the abundance of UV radiation coming in is, in fact, providing the energy needed to produce CH3+. This clearly shows that ultraviolet radiation can completely change the chemistry of protoplanetary disk, said Oliver Berney of the French National Centre of Scientific Research in France, the lead author of the study. He said in a press release it might actually play a critical role in the early chemical stages of origins of life. The team's work was published June 26 in Nature. So there it is. Some very interesting things happening out at our Orion Nebula. Just checking my inbox. Email is still active and YouTube is still active. You're tuned to ASV Radio, VK3 EKH, broadcasting from Narre Warren South. Alrighty then. Happy Asteroid Day. You can celebrate with this free webcast 2 hours ago. There's a live stream that starts at 10 a.m. ET today on June 30, and I suspect if anybody wants to sit in on it, they can still catch it. It's called the Asteroid Day Space Lecture. Today is Asteroid Day. Of course, there's no need for concern. No dangerous asteroids are predicted to be heading our way. Rather, the United Nations commemorates Asteroid Day every June 30, and the anniversary of the famous 1908 Tunguska event, in which an incoming space rock flattened about 800 square miles, or just over 2,000 square kilometres of the Siberian forest, to get it right. Asteroid Day is an annual celebration of asteroid science, an annual reminder of how important it is to study these objects to protect future generations of Earthlings from the damage that might cause if they strike the planet. And of course there is an artist's impression of an asteroid coming into Earth's atmosphere, which I shall bring up. And there it is. The main Asteroid Day festivities are in Luxembourg, with the primary festival there actually occurring on Saturday, July 1. All day long, scientists, space explorers, universities will feature talks and demonstrations. There will be an astronaut's autograph session. Asteroid Day will also feature a live broadcast from scientists and astronauts at 10 a.m. EDT or 1400 hours GMT. You can watch it in the window above or here. That's what it says. Asteroid Day is also celebrated by dozens of local events hosted all across the globe. Many are online, including free talks from scientists and astronauts. A number will focus on NASA's recent DART mission, which successfully crashed into and redirected a small asteroid last winter over in the Northern Hemisphere. Other events are in person. For example, there's a talk in a museum in a certain place in Japan, a children's space camp in Brisbane, and a star party in Southern California winery. Amazing places to go to. Asteroid Day began in 2014 as a collaboration between Apollo 9 astronaut Rusty Swishcart, asteroid safety advocate Dan Remy, filmmaker Greg Riches, and Queen guitarist Brian May, who also happens to be an astrophysicist. In 2016, the program gained the official backing of the United Nations. So that's all happening tomorrow, I suspect, this weekend, so on 1400 hours GMT. Oh dear. This is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. Okay, next article. Alien Planet. 10:30. A captured alien planet may be hiding at the edge of our solar system, and it's not Planet X. Let me just check my YouTube. Yep, YouTube is still there. Right. The cold and mysterious Oort cloud at the edge of our solar system may be hiding a rogue exoplanet, new research suggests. This was published 18 hours ago, courtesy of space.com. In 1906, astronomer and businessman Percival Lowell launched a search for Planet X, a hypothetical giant planet orbiting the Sun beyond Neptune. Lowell was convinced that Planet X existed based on some supposed irregularities he had observed in the orbits of Neptune and Uranus. His belief eventually led to the discovery of Pluto in 1930, though scientists later determined that the dwarf planet was too small to have a gravitational impact on Neptune's orbit, let alone Uranus's. Today, the Planet X hypothesis is largely considered to be discredited. However, that hasn't stopped astronomers from looking for planets in far reaches of the solar system. And according to a new study, they might be out there, only much further away than Lowell could have predicted. An international team of researchers recently simulated the unstable celestial mechanics of this early solar system. They found that there is a possibility that one or more planet-sized bodies came to rest in the Oort cloud, a vast collection of icy objects stretching between a few 100 billion to several trillion miles from the Sun, according to NASA. The new paper describing the work has been published to the reprint server ARXIV and has yet to be peer-reviewed. But having said that, approximately 4.5 billion years ago, when the solar system was first forming, it was an unsettled place. Gravity sent debris from the rapidly cooling protoplanetary dust cloud pinging around like cosmic pools of balls. Occasionally, the researchers calculated large pieces of debris, even planet-sized ones, would have been hurled far enough to escape the Sun's gravity altogether. Scientists have observed such rogue planets wandering around in distant solar systems. According to the researchers, there's about a 0.5% chance that one of these wayward planets might have formed in our own system and ended up in the Oort cloud as it drifted away from the Sun. But the team calculated it's slightly more likely that a rogue Neptune-like planet from another solar system was snagged by the Sun's gravity and came to rest somewhere in the Oort cloud. The chances of this are about 7%, and if this is the case, then an object akin to Lowell's long-sought Planet X might be out there after all, though it would still be too far away to influence Neptune's orbit. However, the researchers think it's most likely that the Oort cloud is made of a collection of much smaller icy objects, given the size and the distance of the Oort cloud, though we might never know for sure what's lurking out there. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of Narre Warren South, VK3 CSJ. 10:34. And just a bit of a plug for astrophys.com if you are interested in listening to some podcasts that Brian O'Brendan has generated over these many years. He's up to Astrophys episode 174. So just go to astrophys.com, ASTROPHIZ, astrophys.com, to be able to find a host of his hosts, web podcasts. That's it. Pleasant good evening, Brian, if you are listening. Brendan O'Brien, that's it. I am definitely tired tonight. Okay, here's an interesting little article looking back into history. 60 years ago today. Sounds like a Beatles song. Anyway, 60 years ago today, Valentina Tereshkova launched into space. I think that's how a correct pronunciation for her surname, Tereshkova. Looks like it. The first female cosmonaut flew years before NASA put a man on the moon, and decades before any other country would send a woman into orbit. Published June 16, and astronomy.com. On a drab Sunday in Moscow, which is just about every day, on a drab Sunday in Moscow in November 1963, a dark-suited man stood beside his veiled bride, whose bashful smile betrayed the merest hint of nerves. Despite the extraordinary lavish surrounding of the capital's wedding palace, it might have been any normal wedding, but for one thing. Both groom and bride were cosmonauts, members of Russia's elite spacefaring fraternity. 2 years earlier, that bride, Valentina Tereshkova, had been a factory seamstress, an amateur parachutist, with more than 100 jumps to her name, when she volunteered for the cosmonaut program. Now, the 26-year-old, whom Time magazine dubbed a tough-looking Ingrid Bergman, was among the most famous women in the world, an accolade she had earned just months ago by becoming the first female to leave the planet. And we've got a picture here of her, all dressed up in a spacesuit. There she is. 60 years on from her pioneering Vostok 6 mission, more than 70 women from around the globe have followed in Tereshkova's footsteps, crossing that ethereal boundary between ground and space. Some have commanded space missions, helmed space stations, made spacewalks, spent more than a cumulative year of their lives in orbit, and even flown with a prosthesis. A woman from Britain, Iran, South Korea have become their country's first national astronauts, ahead of male counterparts. So humble beginnings, born in the tiny Russian hamlet of Bolshaya Maslenikov, 250 kilometers northeast of Moscow, you have to believe me. Tereshkova scarcely knew her father. A tractor driver prior to his service, he died in the Finnish Winter War when she was 2 years old. Her mother single-handedly raised 3 children while also labouring in the Krasny Prokop textile mill. Tereshkova did not begin formal schooling until nearly age 10, and left at the age of 16. Finishing her education via correspondence courses, the young girl worked making coats, apprenticed in a tyre factory, then joined her mother and sisters in the loom. An interest in aviation eventually drew Tereshkov to an air sports club, where she made her first parachute jump at the age of 22. In 1961, she applied to Russia's secretive space program, just as officials were considering flying a woman in space, as the obvious next step after Yuri Gagarin had become the first man in space in April that year. Early in 1962, 5 female finalists, Tatina Shesnesova, Valentina Ponomaryova, Irina Solova, and Zhanzana Yorkina, and Tereshkova arrived at the cosmonauts training facility in Moscow's forested outskirts to learn the rudiments of space travel. All were seasoned parachutists. This was a necessary prerequisite, as during the descent back to Earth, cosmonauts ejected from their Vostok capsules at an altitude of 7 kilometers and landed beneath a parachute canopy. Tereshkova was not top of the crop in technical preparedness or skill. Unlike NASA's steely-eyed astronauts, she was no fighter ace or test pilot or intellectual. Indeed, the best praise bestowed by the cosmonauts' commander, stone-faced General Nikolai Kamenin, was that she was suitably feminine. But her humble origins and gushing support for Russia's Gul ruling regime made her an ideal pawn for Premier Nikita Khrushchev, for whom space exploration and Soviet propaganda were dual faces of the same coin. He desired to promulgate the fiction that under Soviet socialism anyone could go into space. In a high-stakes, high-risk environment, it was a huge gamble. The original mission envisaged either one woman flying for 3 to 4 days or 2 women launching in separate Vostok capsules. But this changed in March 1963. Instead, a male cosmonaut, Yuri Boyarsky, would attempt a record-breaking week-long flight on Vostok 5, with Tereshkov launching on Vostok 6 part-way into his mission for a few day-long mission of her own. But shortly after Boyarsky's June 14th launch, his rocket underperformed and limited his mission from 8 to 5 days. Nonetheless, it still ensured a world record at the time. In Moscow, Khrushchev was hosting a Harold Wilson leader of Britain's Labour Party. When Wilson asked how many cosmonauts Khrushchev had in space this time, the Premier would not help but gloat, only 1 so far. Tereshkov's Vostok 6 mission launched at 12:29 p.m. Moscow time on June 16. The rocket sent her into an orbital configuration that caused her spacecraft and Boyarsky's to naturally pass within 5 kilometers of each other twice a day. 3 hours after liftoff, Tereshkov heard Boyarsky's radioing her call sign, Seagull, and the pair were soon in regular voice contact. At one point, Boyarsky quipped that Tereshkov was singing songs for me. Her 3-day mission proved a political triumph for the Premier, surprising all of the NASA's Project Mercury astronauts' time in space combined. She photographed terrestrial cloud cover and land masses beneath her flight path and was astounded by the light blue, beautiful band of the horizon over the poles. But rumours swirled that Tereshkov did not adapt well to the strange weightlessness environment, appearing tired and weak in televised images from space. She suffered motion sickness, consumed barely half of her food, and grumbled about a lack of provisions to clean her face or teeth. She found the provided bite-sized chunks of bread dry and tasteless, and despite Tereshkov's penchant for Vostok's fruit juices and cutlet pieces, she began craving Russian black bread, potatoes, and onions as her missions neared its end. That end came June 19th. After 70 hours and 48 orbits, the capsule's descent was commanded automatically. After ejecting, Tereshkov's mistakenly opened her helmet visor and was struck by a small piece of falling metal. The glancing blow left a nasty cut on her face. Barely missing a lake in the prevailing wind, she landed safely and was welcomed home by a clutch of kindly, though somewhat perplexed, locals who offered her fermented milk, cheese, fat cakes and bread. And there's another picture here. She's in some sort of conference here. So to finish the article, it's a complicated legacy. Following Vostok's 6 success, Khrushchev crowed that Russia offered its women a fair better lot than the capitalist West. Under Soviet socialism, he said, women could prosper and reach the stars. But the propagandist reality of Tereshkov's flight was laid bare when no more Russian women entered space for another 2 decades. Even today, the total number of female cosmonauts can be counted on 2 hands, accounting for just 8% of all women launched into space to date. Like Gagarin before her, who logged the shortest orbital mission by any male spacefarer, Tereshkov's time in space is also the shortest of any woman's. Neither flew again, as Gagarin was killed in an aircraft crash before he could complete a second mission. Tereshkov earned a doctorate in aerospace engineering and became active in politics. Although she was sanctioned by the US in the year 2022 for her support of Vladimir Putin's attempt to annex Ukraine, Valentina Tereshkov's spaceflight remains a shining example of their triumph of the human spirit over fierce diversity. This is VK3EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast. Coming to you from the studios, VK3CSJ in Narre Warren South. I did very quickly read that article just to scan over it. I always find Russian names very difficult to pronounce. But I thought it was an interesting article. Anyway, all right. Okay, so 1047. 1047, where are we? I'll go to here. And there's no pictures on that one. Okay, update. Or updated. A major neutrino announcement is happening today. Published 29 June 2023. Spacealert.com. It's shaping up to be a huge week for space and physics news, with 2 major press conferences about the universe announced for Thursday, 29 June. They may share a date, but they're both very separate announcements. And from what we can tell, very distinct discoveries that will be shared with the public. Let's dive in and get up to speed with what we know so far. Gravitational wave discovery, updated 29th June. This announcement has been made and it's official. Scientists have detected the background hum of the universe. Detecting this background hum is a huge deal, as it could revolutionize our understanding of the earliest days of the universe. For example, electromagnetic radiation does not provide a picture of the universe any earlier than the time of the last scattering, about 400,000 years after the Big Bang. Gravitational waves, however, can give us information all the way back to the onset of inflation, just 10 to the power of 32 seconds after the Big Bang. Theoretical physicist Susan Scott of the Australian National University and the ARC Centre of Excellence of Gravitational Wave Discovery told Science Alert's senior journalist Michelle Starr back in January. Teasing out this faint background hum from all of the other sounds in the universe was incredibly challenging, but scientists were able to do so using pulsar timing arrays. Pulsars are a type of neutron star, the remains of once massive stars that have died in a spectacular supernova, leaving just a dense core behind. These rotating stars act like cosmic lighthouses, with their beams of radio emission sweeping over Earth at precise intervals. Gravitational wave ripples should, in theory, produce tiny irregularities in the timing of these pulsar flashes. One pulsar on its own wouldn't signal much, but a large number of pulsars all showing similar inconsistencies would represent the kind of gravitational waves we'd expect to see produced by the mass merging of black holes in the early universe. While the researchers are stopping short of claiming that they've detected gravitational waves just yet, they've got a very promising fingerprint, and more data should reveal a clearer picture. Now, the other interesting discovery is a neutrino discovery, 29 June. The second announcement is in. We've officially detected high-energy neutrinos coming from within our own galaxy. They've given us the first neutrino map of the galactic plane and also hint at the origin of mysterious cosmic rays. The discovery was made by the Ice Cube Neutrino Observatory built deep within the Antarctic ice. This particle detector looks for neutrinos, subatomic particles that are incredibly challenging to detect due to their lack of charge and a mass that virtually is non-existent. This spectre-like ability to pass through our world unnoticed has earned neutrinos the nickname of ghost particles. It also makes them ideal subjects to study distant cosmic events, as their path and characteristics remain relatively unchanged by their surroundings as they fly through space. Neutrinos are emitted as part of the beta decay process that turns neutrons into protons, which makes them one of the most abundant of subatomic particles in the universe, with tens of billions hitting your fingernail every second without you even noticing it. We've previously detected neutrinos from distant quasars, particle colliders, and even our own sun. They've even a candidate for the mysterious material known as dark matter. Well, that's the end of the article. All right, full stop on that. Okay, so it's claimed that we finally have discovered neutrinos. So there's more to come on that one. Stay tuned here. All right, now in light of the recent earthquake, I thought I've actually held over this article from last week, so this is rather timely since we've all had a bit of a tremor last night. Earthquakes seem more intense after cosmic ray strikes. Scientists say this is why. This was published 8 days ago. An underlying mechanism might be responsible. Earth seems to shake more after intense cosmic radiation hits its surface, a new study suggests. The surprising study by a team of Polish researchers analysed 50 years' worth of data and found that the intensity of global seismic activity correlated with the average variation in the intensity of secondary particles created by cosmic radiation with a large lag of around 2 weeks. Secondary cosmic radiation is produced by the interactions of cosmic rays and the Earth's atmosphere, which suggests that the link between two phenomena may have nothing to do with the intensity or of the arriving cosmic rays, but rather with the ability to breach the Earth's defences. The team said that they ruled out the possibility that the observed correlation was down to chance alone. If a connection is confirmed, scientists could use it to better predict powerful earthquakes that cause massive structural damage and human casualties, potentially reducing the impact of such natural disasters. At first glance, the idea that there is a link between earthquakes and cosmic radiation in its primary form reaching us mainly from the sun and deep space may seem strange. Cosmic ray extremely distributed observatory, or CREDO, CREDO, coordinator Petra Polymer said in a statement, however, its physical foundations are fully rational, he says. CREDO, CREDO, is an international virtual cosmic ray observatory that collects and processes data from a range of detectors, from sophisticated scientific instruments down to the ordinary smartphones of volunteers. That's interesting. Its prime aim is to monitor global changes in the flux of secondary cosmic radiation reaching the surface of our planet that is created in the stratosphere when particles of cosmic radiation collide with the gas molecules and trigger a cascade of secondary particles. Scientists think that the strange correlation between cosmic radiation and seismic activity could be explained by the behavior of eddy currents in the liquid core of our planet, which derive the generation of the Earth's magnetic field. This field, also known as a magnetosphere, is responsible for deflecting charged particles which make up cosmic radiation. The team reasons that large earthquakes may be associated with disturbances in the flow of matter that drives Earth's dynamo, which also affects the magnetosphere. This would, in turn, affect the ability of primarily charged particles to penetrate the planet's atmosphere, which would then have an impact on the amount of secondary cosmic radiation particles detected on the planet's surface. The CREDO team looked at cosmic ray intensity data collected by the Neutron Monitor Database project at the Peri Auger Observatory, Peri Auger Observatory, with these observatories selected because they sit on different sides of the equator and use a varied of detection methods. The data sets were cross-checked against changes in solar activity detailed in the Solar Influences Data Analysis Center database, and information regarding seismic activity recorded by the US Geological Survey Program. Using several statistical techniques, the scientists saw that for the period studied, a correlation between changes in the intensity of secondary cosmic radiation and the summed magnitude of all earthquakes with magnitudes greater than or equal to 4 emerged. This correlation may manifest when cosmic ray data was shifted ahead of the seismic data by 15 days. The fact that the changes in cosmic radiation come before the Earth tremors suggests the correlation could be used as a foundation of future earthquake warning system. What isn't clear from the team's research, however, is whether this apparent correlation could be used to predict where on Earth an earthquake will strike. This is because changes in cosmic ray intensity and earthquakes were only correlated when seismic activity on a global scale was taken into account. The correlation disappeared in the location-specific analysis carried out by Credo. In the scientific world, it is accepted that a discovery can be said to have been made when the statistical confidence level of the collaborating data reaches 5 sigma, or standard deviations. For the observed correlation, we obtained more than 6 sigma, which means a chance of less than 1 in a billion that the correlation is due to chance. We therefore have a very good statistical basis for claiming that we have discovered a truly existing phenomenon. The research exemplifies the fact that Earth's massive magnetic field can actually act as a huge and extremely sensitive particle detector, many times larger than any human-built instrument that does the same job. The most important thing at this stage of the research is that we have demonstrated a link between cosmic radiation recorded at the surface of our planet and seismicity. And if there is anything we can be sure of, it is that our observation points to entirely new and exciting research opportunities. Okay, that's about it. So there it is. I held over on that one, but I thought because of our interesting earthquake last night, which happened to be 4.6 on the Richter scale, it might have been related to some cosmic ray radiation. Also, I'm not too sure about that though. Anyway, let's get on to spaceweather.com. This is VK3EKH. Okay, spaceweather.com. The solar wind is currently at 499.7 kilometers a second at a density of 1.6 protons per cubic centimeter. The current disk of the sun, which I can just pop up on screen right now, there it is. That's the current disk of the sun, 30th of June. We have several sunspots on the surface of the sun facing us as we speak. The current sunspot number is 112. The radio sun is currently at 162 solar flux units, measured at a wavelength of 10.7 centimeters. The K-index, planetary K-index, is currently KP is currently equal to 2.33, which is considered quiet. The 24-hour max KP figure is 4, which is considered unsettled. The current auroral oval over the... I didn't pass it through. There's always something I forget to do. Let me just... I did save it, and I think, therefore, I am... which one is it? I think it might be... I think it's that one there. Alright, up on the screen as we speak is the current... Yeah, that's it. The current auroral ring over Antarctica, and it's extending out towards the south of Tasmania there, so there's a little bit of auroral activity going on. Again, not much to write home about, but it is there and doing some small influence. Okay, the other part of this story is there will be a minor geomagnetic storm watch. NOAA's forecasters say that a CME might graze Earth's magnetic field on July 1. July 1. It was launched into space 3 days ago by an erupting magnetic filament in the sun's northern hemisphere. The glancing blow, if it occurs, could spark a minor G1 class geomagnetic storm this weekend. Now there's an interesting picture here of a sunspot, quite a close-up view of a sunspot. It's in black and white though, but it still looks pretty impressive. So if you're watching the repeater, or YouTube's still streaming away there, I can see. We haven't dropped over yet. But there's a nice close-up view of a sunspot. A giant sunspot alert. When this week began, sunspot AR3354 didn't exist. Now it is 10 times wider than Earth and still growing. The sunspot burst into view on June 27, breaching the surface of the Sun, then blossoming into a giant over the next 48 hours. AR3354 is so big amateur astronomers can see details normally reserved for the world's greatest telescopes. Michael Carrer sends his picture of the sunspot's dark heart from his backyard observatory in Austria, and that's what we're seeing on the screen right now. Despite its gigantic size, the sunspot was not as easy to photograph as expected, says Carrer. The jet stream brought verbal seeing to my observatory, he says, but in a few moments of fair conditions I was able to capture this high-resolution image. Carrer's photo shows that the sunspot's heart is not completely dark. It is peppered by umbral dots, incandescent balls of plasma rising and falling in the sunspot's core. Researchers believe they are turbulent convection cells which dredge up heat from 1,000 kilometers below. The same kind of motions can be seen in a pan of water boiling on a hot stove. The photo also resolves hundreds of penumbral filaments, fine magnetic tubes that transport energy out of the sunspot. While many astronomers are using telescopes to examine the sunspot, telescopes are not required. AR3354 can be seen without any magnification. If you have special eclipse glasses, put them on and take a look. But don't look at the sun directly, of course. They always say that. Anyway, it's a wonderful picture though, isn't it? I'm always gobsmacked when we get close-up images of the sun, especially when it's a film, video, or something of some such nature. Alright, I think that's about it for this night. Let me just check if there is anything else. Talking about cosmic rays, I did have the map of cosmic ray radiation. Let me just bring that up very quickly for those watching the video side of the thing. I didn't move that across either. Oh my goodness, I thought I had, but there it is. Just a second. We all should do it. It is just here, and there it is, and do that, and do that, and do that, and there it is. Okay. So for those watching the video side of it, the current chart there shows solar cycle 25 begins. So as the solar cycle ramps up, cosmic radiation actually decreases due to the increase in solar's radiation on the Earth's atmosphere. The charged particles in the Earth's atmosphere, as a result of the increase in the solar activity, actually reduces cosmic radiation reaching the ground. And the chart that on the screen right now actually shows that over the last since the beginning of the solar cycle 25, cosmic radiation has actually been being reduced, which also kind of suggests that, in reference to my last article, that if there's a reduction in cosmic radiation, then the correlation between that and earthquakes would be coming up to a minima. So what can we say about that then? Anyway, that's just a thought that I had then. Where is it? There it is. Near-Earth asteroids, and we did have a near-Earth asteroid this week, although it wasn't worth worrying about, but it did come pretty close to us. But as of June 30, 2023, there is 2,335 potentially hazardous asteroids. All right, so on that, I shall conclude tonight's broadcast. Thank you, Kim, Martin, Steve, Martin, Steve, Martin, Steve, Martin, Steve, Kim, Steve. That's how it just reads out on the Discord window. Oh, and now David has just chimed in. our Mount Burnett Observatory. What's the word? Can't think of it. But anyway, David, VK3KDM, he's just put up a seismograph of last night's earthquake, measured at Vermont South. Yeah, it's pretty good. Yeah, you know, we used to have a seismograph up at the observatory up in Heathcote. There's a new one running at the moment, but unfortunately the data's not being presented to the website. So we used to be able to see earthquakes on the old seismograph, and you know, it used to be able to see earthquakes as far as 16,000 kilometres away. It used to work quite well. But even though it was sensitive enough to detect these larger earthquakes so far away, local earthquakes, it didn't really look at too much. So anything under magnitude 3 sometimes would be barely detected. So there's strange sensitivity on that machine. But this new seismograph that we've got running at the moment most likely would have picked this up, but unfortunately the data isn't being broadcasted to the internet at the moment. Anyway, thanks for that, David. No worries, Kim. Thanks, chaps that have sent me emails up there. Very muchly, very kind. All right, my eyes are about to fall out of my head, so I shall now quit for tonight. No, I'll do a quick callback. So, and on 80 metres, and see if there's any stations wishing to check in. This is VK3 EKH on 3541 kilohertz, listening on frequency for any stations wishing to check in.
VK3 BSF.
I wonder if the band is fallen out somehow. VK3 TJS, VK3 SBX, VK3 BSF. Is there anybody else wishing to check in? Okay, got VK7JH. There was another station just then. Who was the other one? Okay, if there is somebody there, very weak. Take it, Jack. VK3 TJS Shepparton, VK3 EKH. Yeah, sorry, Jack. You're a little bit tricky to hear tonight. You're not as strong as previous Fridays. I'm not sure if you've got you're running your linear there or not, but you're down a little bit down in the noise and just slightly off frequency. I was fiddling with the BFO here or clarifier to try and just adjust you a little bit. So just a bit of a trick to hear you tonight. Unfortunately, Jack. Strange propagation is not so good. Up north. I'll just quickly put it back to you. VK3 TJS, VK3 CSJ. Just try again. Yeah, I mean I'm hearing you, but I'm not sure if you're asking a question there, Jack. Try again. All right, mate. Sorry about that. That just wasn't a very clear signal to me tonight. I mean, last week you were about 20 over 9, but tonight just a little bit on the weak side, so just a little bit tricky to hear what you were saying. Sorry about that, mate. Yeah, just the way the band is, I guess, at the moment. Thanks, Jack, anyway. It's fine. All right, Steve, VK3SPX. You weren't very strong either. VK3SPX, VK3EKH. Oh boy, you're almost as bad as Jack. Dear, thank God for the repeater and YouTube. Anyway, yeah, no, you're about the same strength, if not just a little bit weaker than Jack. In fact, Martin down at Launceston was quite strong, apart from Peter. So I don't know. It's really interesting. I'll blame this on the solar cycle. Maybe it's the earthquake. Maybe it's done something. Sorry, Steve. Having trouble with you tonight too. You. Anyway, thanks for checking in. That's the main thing. Peter. Now, Peter's a local lad. Not a problem with Peter. VK3BSF, VK3EKH.
VK3EKH, 3BSF. All good. No copy on Jack or Steve. But very interesting that the earthquakes are caused by cosmic radiation. Oh, very well. And the 5 standard deviation stuff. Yes, they seem to find the figures that confirm their findings, I guess. Didn't hear the space weather report. What happened there? But everything else was great, mate. Put it back to you, 3KH, VK3BSF.
Well, there was a space weather report. That was the spaceweather.com. I usually do feature that towards the end of the session. I go across to the spaceweather.com page. So is that what you're referring to, or the Space Weather Woman, Timothy's report?
Yeah, Timothy. She was the one. She really gets into it.
Yeah, she does, doesn't she? No, look, like I said earlier on in the evening, I'm always checking her website before I go on, just to make sure. I'm going to do a quick check now, just to see if there is anything there by any chance. But no, see, her latest report's 6 days ago. So her last report followed up, I think, as far as Wednesday last week. So I could have run it just from a historic point of view, just a kind of a report that fills in what's occurred over the last week, I guess. But no, I didn't bother to do that. So the chances are that she'll put out something tomorrow. It's unfortunate that her release of her space weather doesn't quite correlate when I go to air on a Friday night. But if there is a new report that she puts up in the next day or so, I'll certainly put that up next Friday for sure. Yeah, I know what you mean. Yeah, she well and truly gets so the enthusiasm is overwhelming. Okay, thanks, Peter. And it's interesting that you're also getting a weak signal on the other chaps too. Anyway, it seems okay down to the south though. Martin from Launceston wasn't too bad when he called in. How's the signal, Martin? VK7JAH, VK3EKH. Oh, Martin, I had trouble hearing you, mate. Had trouble capturing anything you were really saying. You're about the same strength as all the other lads. Ouch. Except for Peter. When you first called in, you were quite readable, quite strong, but you've fallen back down into the noise. All right. Yep. Sorry, Martin. Didn't quite capture any. If there was any questions in that, I didn't exactly get it. But you can, if you want, put a question up on Discord, and I'll see if I can answer it if that's what you're wanting to do. All right. Sorry, Martin. The band's just fallen over in this last half an hour, I guess, or so. Is there any other stations that are reasonable signal strength, hopefully, wishing to check in? VK3EKH. There's a very, very weak station there. Not sure who that was, but somebody did try to call in, but exceptionally weak. I don't think it's worth trying, but we'll try again. VK3EKH listening. Look, I can hear somebody there, but it's not clear. Yeah, sorry, chaps. Look, the band's sort of fallen over, so it's just making it a little bit hard. Like everybody should be of good signal strength. Normally, Jack, Steve, and Martin, they're all quite readable, all quite strong. But it looks like the short skip has fallen over in the band tonight, so we'll leave it alone at this stage. So thanks for checking in anyway. I do appreciate it, and thanks very much for calling in, and for everybody that's come up on the Discord there and the internet email. Everybody have a nice warm weekend. Try and stay warm, and we'll see you all next Friday. In fact, I think I've got next Friday off. Have I? Actually, Monday's an RDO, and Friday we've been asked to take Friday off because there's just not enough work at work. So I've had to take it as an annual leave day. Anyway, that's another story. Cheers, everyone. Good night. Take care. Thank you very much for listening. Hopefully, you've been able to hear most of what I've said. This is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, concluding transmissions for tonight. More information about the society can be found at www.asv.org.au. This is VK3 EKH. Cheers, everyone. Okay, I think that's about it. No local lads. All right, so we shall conclude here on the stream and the repeater. This is VK3 EKH with VK3 CSJ on the microphone. Thank you for watching the YouTube. We do apologise for the internet also falling over halfway through tonight's session. But it's been good on the second round. So for those that are watching YouTube, thank you for viewing. Don't have to worry about subscribing or ticking the bell like they all say. I'm not interested in that nonsense. So we shall see you next Friday if you wish to check in. So we shall just finish with the stream. Oh, before I do, might as well clear with the repeater. So yeah, everybody watching the ATV repeater, cheers. We'll be next on air on the TV on Sunday morning at 10:30 with the WIA broadcast. Try to listen in for my AM broadcast on 160 metres. I'm now broadcasting the news, the WIA news, on 160 AM on 1825 at 9 o'clock. So I would appreciate some signal reports on 160 AM, 1825 kilohertz, 9 o'clock Sunday morning. Then at 10:30 is the video version broadcast at 10:30 on the repeater and YouTube, and then repeated at 8 o'clock on Sunday night. I think that's it. And not forgetting that Tuesday is the ATV Net, which I've neglected to come up on the last couple of Tuesdays. My apologies for that. I'm not even sure if I'll be there next Tuesday, to be honest, but we'll try. Anyway, pleasant good evening, everyone. Take care. Thank you for watching and listening. This is VK3 EKH with VK3 CSJ on the microphone. Concluding transmissions from the studios of VK3 CSJ. If I can just find my colour bars. There it is. All right. Cheers, everyone.